Hello, everyone. I'm so happy to be here to present about a topic that I'm very passionate about, which is how to write the next generations of user experiences using Unity and augmented virtual reality. So experiences in the 3D space. My name is Davide, and I'm a senior software engineer living in London. I've been working with these technologies since 2017, firstly with HoloLens, and more recently with other devices like Oculus Rift or Oculus Quest. In the past, I've been awarded the Microsoft MVP for 5 times, and I like usually to share my ideas on my blog or on Twitter or on GitHub. So let's introduce the agenda for today. We will start by talking about mixed reality and define the mixed reality concept, and then build a quick sample using Unity and the SteamVR plugin for desktop VR. Then we will see how the Oculus Quest Passthrough API enable the vision of the surrounding around us from an occluded display, and the more advanced form of interactions with the hand tracking and more complex topics like telepresence using point cloud streaming from a Kinect device. Let's introduce mixed reality as the blending of two realities, the physical reality where we live every day and the virtual reality completely generated by a machine, by a computer or a device. It's where the magic happens, where we can augment our environment with digital objects, or we can pin virtual screens to the wall or choose a new type of furniture without going directly to the shop. To better illustrate this concept, I like to refer to the physical digital reality spectrum that was introduced in 1994 in a paper by Paul Milgram and Fumio Kishino. In this paper, we can put in the two extremes, the digital reality, completely generated by a machine, and the physical reality where we live, and perform a categorization of all the possible experiences and the devices that generated those experiences. So for instance, for the digital reality, we will have to generate completely a 3D world. And we have devices like Valve Index or Oculus Quest 2 or HTC Vive or Cosmos that are occluded displays. So we need to generate completely the 3D world. On the other side, we find the other category of device like HoloLens or LinksR or RealWear HMT1, where we can see through, and then we will have to apply some different consideration when developing those kind of experiences. How can we design for AR VR? It's clearly a different paradigm from the 2D user experiences. So we will need different manipulations, different type of pointy objects, but we also will need a different way of designing of the experiences. I found very useful these 3 types of illusions introduced by Professor Meslater of University of Barcelona. He defined a great VR experience to need 3 types of illusion: the place illusion, so representation of the place where we are, and a 3D place that must be generated on a correct scale to give the sense of presence to the user. The plausibility illusion, the capability of interact with the environment, with digital agents, for instance, or if there is a door, be able to open the door, or if there is a desk, be able to position a virtual object on that desk, so to not break the concept of illusion. And embodiment illusion, representation of our body in the 3D world. So in this video, we can see an example of embodiment, which is performed on an Oculus headset. We can see how the representation of our hands and the various manipulations that can be performed with the touch controllers are quite important to give a sense of presence to the user. And here, this is an experiment that I did when I was studying a specialization with the University of London, the sense of plausibility with a virtual character which is looking at myself directly in the camera. I give the user this sense of immersion, to be there. As mentioned before, when we are working with these 3D interfaces, we need a new way to interact. We don't have anymore a mouse or a keyboard, so we need to have different point of interactions, like gaze for pointing to virtual objects. Voice is particularly important because it gives this sense of natural interactions with the environment, and I am a big fan for voice interaction in virtual or augmented reality applications. And clearly other capabilities like spatial audio, so having the audio cam from the 360 degrees environment around us, and spatial mapping for capabilities of mapping the environment around us, particularly important in experiences like the HoloLens one, for instance. Hand tracking, having the capability of tracking directly the movement of our hands and representing them in the virtual worlds, and eye tracking, so completely different form of interactions. For VR, we have some probably reduced forms of interactions, but they are particularly important because they need usually the some particular sensors or different devices that enable pointing, selecting, or grabbing objects. And of course, the capability of moving in the environment via the concept of locomotion, which is particularly important, which must be developed in a way to not give motion sickness to the user. Because if you want to move from point A to point B in a virtual environment, the sense of motion to the user can give motion sickness. So teleportation is quite a good way to not give motion sickness to the user by pointing a specific point in the area and being moved to that point in area with a smooth transition and gradual transition to not give motion sickness. So let's see how to create a quick experience using the SteamVR plugin using Unity 3D. So if we jump on Unity here, we can have some scene. This is a simple scene that Unity provides with some simple objects. We can usually just import from the Unity package manager the SteamVR plugin from the store. I have already imported here in the project, so we're already good to go. And the SteamVR plugin will add a new folder to our projects. And then we can start from this folder by choosing the prefabs that are important for our scene. A fundamental prefab in SteamVR is the player prefab that can be found here in the SteamVR folder. If we drop the prefab directly in our scene, for instance, here already dropped a player prefab under a game object named VR camera rig, so I can refer to it later if I need to. So this one provides all the basic functionalities for virtual reality, provides two cameras, one for the right eye, the other one for the left eye, interaction with the touch controllers, for instance, representation of the hands if needed with the Oculus SDK in that case, and so on. So usually we have this player prefab in Oculus is called OVR camera rig. It performs similar functionalities, and this will enable the virtual representations of our camera view for the experience. After we can add some additional interaction, of course, to our scene. We mentioned teleport before. A way of adding teleport in SteamVR is by dragging a teleporting prefab, which is available in the SDK. The teleporting prefab already added one here in our scene. By adding this, we can enable the different teleport functionalities in our scene, and then we can specifically decide to teleport to a specific point in our scene. Here I added a prefab for teleport point. It means that I will be able to teleport directly in these specific coordinates of the world. Or I can add a teleport area. So if you look here, for instance, on the ground object that represent our play area, I added a teleport area plane, and to the teleport area plane, I added a teleport area script, which is available in SteamVR. And this will enable teleport in our environment in a very, very simple way. We can add, of course, the other form of interactions, which is object interaction. So here we can find some objects in this table, and by simply adding some scripts that are named in particular interactable or throwable in SteamVR, we can add this form of interactions in our environment. So if you press play, we will need before it some basic configuration on our project. So usually in the player settings, you can set the plugin management here. So depending if you're using Oculus or SteamVR or OpenXR devices, you can here set the corresponding driver that you want to use for the virtual reality experience. And then by press play, executing it on the desktop, we will have our experience running on the headset. You can see here, this is running on a Windows mixed reality headset. So I can turn around, look at the environment around me. I can perform the rotation using the controller, and then I can operate the teleporting that we enabled before with the teleporting prefab. We can move around in the environment. After moving in the environment, we can just, for instance, start interacting with some objects if they are enabled for interaction, or with throwable scripts like the one we described before. With SteamVR, you can see the physics is applied automatically. If we add some rigid bodies, if we add some colliders directly to them, we can also interact with the other different objects. So to summarize, we can import the SteamVR plugin in a Unity scene, add the player prefabs for enabling virtual reality functionalities, adding throwable or other scripts for manipulating the objects, and teleporting for moving in the environment. SteamVR also provides some very interesting functionalities, some abstractions. So you can just define some specific functionalities that can be shared across different controllers, and some actions that can then be mapped to different buttons or different functionality in the controller. So you can reuse your experience across, I don't know, Windows Mixed Reality or Oculus or SteamVR. And here is an example of functionality we saw in the demo of how to rotate the player. This is a script that I wrote very quickly just to illustrate. If we react to some changes and some interactions of the user in the controllers, we can rotate on the left, on the right, based on the buttons pressed by the users. And in this case, we can just apply a transform rotation on the right or the left with basic tolerance. And so that's quite very simple to implement using Unity. Let's see one functionality which is quite important when writing multiple headsets targets for our virtual reality application. So suppose you want to write an experience with Unity that must target Windows Mixed Reality, Oculus, and HTC, for instance, devices. Sometimes you have some tiny differences between them that you want to apply to the scene when it's getting executed at runtime. So by creating a VR headset manager, we can map the different camera rigs for the different headset and apply different properties. And encode can be realized very quickly by the XR device API that are available in Unity. We can verify which type of device our experience is running on, and then set or not some parameters depending on it. So very simple, very easy, but very useful. And of course, to enhance the experience using vocal commands, as I explained before, we can use a lot of predefined APIs that are available in Unity, like the keyword recognizer, or if you wanted to apply more advanced form of or interaction, natural language understanding with the LUIS available on Azure, for instance. we want to be covering in this presentation, as I covered in the previous ones. So you can find some material online. Feel free to jump on it later and ping me via email or Twitter if needed, if you need any clarification. But pretty cool stuff for augmenting the experiences with vocal commands or natural form of interactions. So let's see how this basic form of selection interaction can enable the creation of very simple games. This is a game that I created with the SteamVR by simply downloading some assets from the Unity store and applying some simple basic manipulation and locomotion on the environment. So you can see you can move around, you can provide some instructions to the user, apply teleportation on some specific areas of the scene, and move around, collect objects, and so on. So the idea here is with the plugins like SteamVR or Oculus or Mixed Reality Toolkit, it's very simple to produce fully working application prototypes and going to market very quickly. So that's quite a very important feature to keep in mind when developing for developing this type of experience. So let's see performance tips. The performance I mentioned before that motion sickness is something that we need to care about when writing this kind of application, especially with virtual reality. When, for instance, you develop a virtual reality application, you need to have your experience running at 19 frames per second if you are running on Oculus Rift device, for instance. Otherwise, you can provide motion sickness to the user. Or if you're on a mobile device, could be 60 frames per second, like on an HoloLens or Quest, 60 frames per second, 72 frames per second, 90 frames per second, depending on the type of hardware that you're using and the type of firmware that you have available in your device. So you need to perform a lot of consideration while writing these applications. One script that I found very useful in my development is this one, is a static check, because all the not moving object you're seeing should mark it as a static for helping the rendering on the screen and optimizing the experience. So in this way, and with this script, I can perform a static check on all the object, and if the object is not marked as static, I can provide some debug information on the console for development purposes. I found this quite useful personally to when I forgot, for instance, to mark some object as not static. This script could give me additional information. Reducing the number of draw call is particularly important, and this can be done in several ways. So one is to just use baked lights. So real-time lights in virtual reality application are very expensive, but if we use baked lights, this enables optimizations and better performance on our scene. So very important to use baked lights. For reducing the number of draw calls, other techniques can be to combine mesh materials. So if we have different objects using the same type of materials or the same material, instead of creating different materials for each object, by merging together the materials and making the object pointed to the same material is optimizing the draw calls. Some Unity plugins are also available in the asset store and can help with this kind of optimization. Another way of optimizing the performance is not using methods like get components on the update method, as they are very expensive. Caching strings, since strings are immutable, just caching with the private properties, and be sure to reuse these private fields when, for instance, triggering actions on triggers or when you have interaction with different objects in your Unity scene. Another technique, of course, is to reduce the maximum number of polys that you have in your scene. So you need to take into consideration here if the experience is running on a mobile device or on a desktop device. Usually for desktop devices, you have 1 million, 2 million polys, depending on the performance of your desktop workstation. On mobile devices, 200,000, 300,000. That's really variables, but the order of magnitude is that one. So we need to be very careful to reduce and do not, for instance, render some polys that are not needed. If you are rendering some furniture, probably you don't want to render the all the areas that are not seen by the user, because it's more computational power that is not really having any visual effect for the experience, but it's only having performance degradation. Optimize the garbage collection. So if the experience needs to run 90 frames per second, garbage collection is very expensive as an operation. So if you do gc.collect, it's quite bad for performance. Some recent functionalities in Unity enable the usage of incremental garbage collection, can be enabled directly in the player options. And of course, try to having this collection of objects between, for instance, scene loading, all the other tricks where the user is not really needing the experience at the full frame per second. And usage of object pooling is a technique commonly used in Unity. I have an example of my GitHub. If you look at the URL that I put in this slide, you can grab the source code from there and play with it. So here the idea is try to not instantiate objects at runtime, as this is another way of degrading performance in virtual reality applications. So just use the object pooling. So when your experience is starting, your scene is starting, you create a collection of objects that are enabled or disabled on the scene at runtime. So for instance, if you have some projectiles in your scene, you can, instead of instantiating the projectile every time, add the instances of these projectiles directly in an object pooler. So very useful performance optimization for virtual reality applications. So let's see now how to explore the Passthrough API. So Oculus Quest is a type of virtual reality headset, so it has an occluded display. It means that all the 3D scene needs to be completely generated on the Unity application. But recently, some Passthrough API have been introduced. So taking advantages of the camera available in the Oculus Quest, we can not only having the tracking, but we can also see the surrounding. And then in this way, we can start to write mixed reality application with the Oculus Quest through the Passthrough API. So Passthrough API are still in experimental mode and need to be enabled using the experimental feature using ADB. So this is the command you need to use for enabling the Passthrough API. This operation needs to be performed at the moment every time that you boot your device. So that's quite important to remember that, otherwise Passthrough is not working. Then the Passthrough feature that needs to be enabled in the manifest of the app, in the Android manifest that's get deployed with the package. And the OVR camera rig need to have these experimental features enabled and Passthrough capability enabled to have the surrounding available when the application is running. And an additional Passthrough script when we can also customize the edge rendering of the external environment and the edge color, which can enable also very interesting effects in our application. So more information are available on the developer portal of Oculus in the Passthrough API endpoint. New SDKs also have been recently announced, very important for enabling mixed reality experience with Quest, like the voice SDK or the hands manipulation SDK. So needed to take a look for those when they will come out, because it will enable very different and very interesting experiences with the Quest. So you can see here one of the example augmented object, which is available in the Oculus SDK integration plugin that we can get from the Unity asset store. So here, also from the package manager, here we can have some interaction with some augmented object, which are 3D object in our scene. So I have deployed this example on my Quest 2. And here you can see how you can see the surrounding still in black and white, unfortunately, in the current version of the Quest 2. And then we can interact with some 3D objects that we can put in the environment. And so this is quite a basic example of mixed reality, but it looks promising for the next iteration of the Oculus SDK. So let's see now how to perform more advanced experiences with augmented virtual reality. So one topic which is particularly interesting at the moment is collaboration, how to be able to use these devices for collaboration in the 3D space. And so one experiment that I wanted to do was experience how telepresence could work with a virtual reality headset. So the idea here was just to try to experiment more advancement that could be included in the future in other products, of course. So at the moment, experiences for collaboration include Horizon Worlds from Facebook for social experiences, or Horizon Workrooms for work-related stuff, or of course Microsoft Mesh for virtual collaboration, holoportation. And my thinking was how would be possible to implement something like holoportation that you can see a lot around with augmented or virtual reality experiences. So I did some research and I found this great project available on GitHub, which is LiveScan 3D, a fast and expensive 3D data acquisition system for multiple Kinect V2 sensors. So this project is capturing points cloud from multiple Kinect sensors, Kinect V2, but Azure Kinect is working as fine. And after capturing this point cloud from the Kinect sensor, the depth cameras enable the streaming of these vector 3 color coordinates on the local area network via sockets, and then capturing these sockets on the device and with particular meshes drawing the point cloud directly on the virtual reality display or the augmented reality display. Of course, this example is working with sockets, but this could be extended with other forms and protocols like WebRTC or WebSockets, etc. So what I did was I ran the LiveScan 3D server on my machine connected to the Kinect V2, and then I had a representation of the point cloud on the simple desktop application available with the LiveScan 3D. After this, I then was able to customize the telepresence receiver available for HoloLens to run on Oculus Quest. So by introducing then the OVR camera rig from the Oculus plugin, I was just able to enable it for Oculus Quest and then reuse the point cloud receiver and point cloud renderer script that are available on the LiveScan 3D projects. So you see here the point cloud renderer and point cloud receiver is just getting the values from the sockets and the values of the different coordinates and the colors of the point clouds. And then it's just drawing with the specific mesh these points on the 3D app. So I also enabled some pass-through APIs on this project. So you can see here I have a pass-through experience using Oculus Quest. I can see the surrounding around me. I applied some edges and with some colors on the surrounding to have a different effects. And then I can see here the points cloud represented on my Oculus Quest application. And so which is particularly cool and clearly could be a starting point for writing a telepresence system using Oculus Quest as a receiver and Passthrough API through. So mixed reality using Oculus Quest and using telepresence via points cloud generated by a Kinect, which is pretty cool scenario in my opinion. So let's see how to implement a more natural form of interaction using hand tracking, which is particularly important for giving the presence, the sense of presence to the user, especially in augmented reality applications. A very powerful plugin for hand tracking and hand manipulation is the Mixed Reality Toolkit for Unity, which of course was initially designed just for HoloLens, but now can be used on a variety of devices. So you can, for instance, get your Oculus Quest running a mixed reality application, which is using hand tracking for interacting with objects. And recently we announced, as I mentioned before, some interaction SDK for Oculus Quest available in 2022. And this will enable additional forms of interaction with objects like manipulation with grabbing keys and interaction, more fine-grained interaction with virtual 3D. So I just deployed here the mixed reality toolkit on Oculus Quest 2 and analyzed the different interactions that can be done with the simple scene. You can see here we can just have interaction with a virtual piano or some virtual slider of 3D objects. And this is particularly impressive considering that it can simply run on very cheap devices like Oculus Quest 2. And they can be used for prototyping HoloLens 2 application very, very simply in this way and apply all the different forms of interaction available with the mixed reality toolkit. And then let's move to the last part of the presentation and see how it's also important to take advantages, not only of the client-side capabilities of the devices, but also on the cloud and all that different services available on the cloud, like, for instance, cognitive services or remote rendering or spatial anchors provided by the mixed reality services by Microsoft. So in this way, we can combine the different sensors available on the devices like the HoloLens and send some computing request to the services and then provide a new sort of experiences. To just prototype this, I created a new computer vision application and a new computer vision endpoint on the Azure cloud. And then I just grabbed some photos from the camera of the HoloLens device, sent this photo to the cognitive services, and then get back some object recognition performed by the cognitive services directly in the cloud. You can see here an example of the recognition of the building, the Microsoft building in Reading, UK. And here just use the mixed reality toolkit or previous version of the Valve toolkit just to capture some voice commands and sending the images directly to the backend to perform the computation and having some basic object recognition directly on the device. So very important feature here, using the sensor capabilities in the HoloLens or in the other headsets, and for a starting point and connecting to the cloud for more advanced capabilities. So just to mention before, different Azure mixed reality services like remote rendering, spatial anchors, or object anchors are particularly important for enhancing the virtual or augmented reality experiences, as of course the development, especially for augmented reality, requires not only the awareness of being in a single place or in a completely 3D generated space, but requires also the capability of interacting with outside objects, to recognize the environments, to be sure that if I position an object in a real table, the object is there when I return there. I don't know, the day after or in the future. So very important, then make use of the mixed reality service. So to summarize what we saw today, we introduced the concept of mixed reality, and we saw different examples how to develop for AR VR, in particular with the SteamVR SDK for virtual reality application, how to apply basic interaction and locomotion in a scene, how locomotion is very important for not providing motion sickness to the user, and performance considerations, very important, and needs to be carefully considered when developing these apps. We need to apply this performance consideration not only at the end of the development cycle, but also during all the development workflow. And then the latest developments in terms of Oculus Passthrough API, the pass-through mode for enabling from the cameras of the Oculus device the view of the surrounding around us, and telepresence, very interesting applications for collaborations in 3D, and LiveScan 3D is a great project for performing holopresence with Kinect and every other device on the market, starting with HoloLens, but then recently with Oculus Quest, with the prototype that I showed you before, and then developing for AR, taking advantages of all the mixed reality services, including cognitive services or remote rendering or spatial anchors and more. And so the key takeaways for me is collaboration is a very important topic and requires further research. There are a lot of papers about it, but I think a lot of research still needs to be done. Very early stages, of course. For instance, it's not simple at the moment doing holoportations because it requires a lot of sensors, a lot of hardware considerations, and the GPU considerations on the server. So that's quite a complex topic. It requires more research. And when performing development, it's important to do performance consideration early and often in the development process. Otherwise, we could find at the end a very bad user experience, and then we'll have to do a lot of development for fix that. Design properly the experience using the 3 types of illusion: place illusion, plausibility illusion, and place illusion, and use cloud services to enhance the user experience. Speech, vision, and anchors as particularly important. And I would like to finish with a phrase from Arthur C. Clarke, Profiles of the Future, that any sufficiently advanced technology is indistinguishable from magic, because this is magic when you're working with these technologies. So thank you very much for your time. I'm putting all these slides online. The samples will be available on GitHub. Some references are here if you want to take a look. I found these references very useful to understand more in depth some stuff around AR, VR. And thank you very much. I will publish online on my blog and on GitHub the samples. Thank you very much.